Alright guys, how you doing? In this first video, I want to go through how we go about solving one-step linear equations. This is where we're going to start with our Algebra 2 course. So my first question I'm going to tackle is going to be this. Show that x equals minus 2 is a solution of the equation 10x minus 14 equals minus 34. So we want to show that x equals minus 2 is a solution to this equation. How do we go about that? Pretty simple actually. All we want to do is check to see if by inputting x equals minus 2 or inputting minus 2 in here for x, does that value make this equation true? And that's really what we mean when we say solve the equation. We want the value for x or the value for the variable that makes the equation true. So here, in this case, I'm going to input minus 2 in for x. So my equation is going to become 10 times minus 2, 10 times minus 2, minus 14 equals minus 34. Okay, distributing this out, I get 10 times minus 2. That's going to give me minus 20. 10 times minus 2 is minus 20. Minus 14 equals minus 34. Gathering up my terms on the left-hand side of my equation, I have minus 20 minus 14. Well, if I do that in my head, I get minus 34. So I get minus 34 equals minus 34. And sure enough, that is true. And so I have now shown that x equals minus 2 is in fact a solution to this equation right here, 10x minus 14 equals minus 34. In fact, it is the solution. So minus 2 is the solution to this equation. All right, so let's try something a little different. Let's try an equation where we're not told what to input for x. Can we find the solution? Can we find the value of x that makes the equation true? So the first problem I'm going to try is x minus 9 equals minus 3. X minus 9 equals minus 3. So what value for x will make this statement, this equation, true? That's what we want to do. What we're going to find over and over and over again is that what we really want to do when we're solving for the variable is we want to get the variable by itself. So we want to isolate the variable on one side of the equation. Oftentimes it'll be on the left-hand side of the equation. We read from left to right, but it really doesn't make any difference, of course. Here I have the variable that I want already on the left-hand side. So what can I do to get this x here by itself? Well, I have a minus 9. How can I bring this minus 9, how can I get rid of it? How can I have just x here? That's what I'm looking for. Well, the way that we do this is we can simply add 9 to both sides. So I can add 9 to the left-hand side of my equation, but of course whatever I do to the left-hand side of the equation, I must also do to the right-hand side of my equation. So I must also add 9 to this side. Whatever you do to the left, you must do to the right. Whatever you do to the right, you must do to the left. You must do the same on both sides of the equation so that you keep the equation the same. All right, well I have x minus 9 plus 9. So that's going to cancel. They're going to cancel each other out, and on the left I will be left with x. On the right-hand side, I'm going to have minus 3 plus 9. Minus 3 plus 9. Again, if I do that in my head, I'm pretty sure I get plus 6. Typically, I will just write 6 by itself, but for today I'll write plus 6 for a little bit more clarity. So x is equal to 6. And so what we have found, what this is telling us, is that 6 is the solution to our original equation. X is equal to 6 satisfies that equation. We could check that. Our original equation was x minus 9 equals minus 3. Well, let's just input this value 6 in here for x. Well, that is therefore 6 minus 9 equals minus 3. 6 minus 9, that is in fact minus 3. And so minus 3 is equal to minus 3. My equation is true. And so I have found the actual value. I haven't made a mistake. My arithmetic, my algebra has been okay. And so I have found the correct solution. That's one way of verifying that. All right, so let's do another one. I will say that I'm actually going to throw up a problem that I'm going to ask you to do. So yourself, x plus 3, this is just like the one we just did, x plus 3 equals 8. X plus 3 equals 8. So I'm going to ask you to try that problem yourself. All right? Okay, so let's try something a little different. If I have the equation minus 7y equals 84. Minus 7y equals 84. What we want to find is, again, we want to solve the equation. Solving the equation means finding the value for the variable. In this case, the variable happens to be y. The value for the variable that makes the statement or the equation true. What value would I need to input here for y that would make the left-hand side of my equation equal to the right-hand side of my equation? All right, so again, the name of the game is always going to be isolating that variable, getting that variable by itself. How would I get my y by itself? It's not quite by itself. Here I have a minus 7 in front of my y. So in order to isolate that y, what I'm going to do is I'm going to divide. The y is multiplied by minus 7. So in order to undo that multiplication, well, the reverse of multiplication is division. And so if I divide by minus 7y, I will ultimately get y by itself because my minus 7y's will cancel above and below. So that's what I'm going to do. I'm going to divide by minus 7y. But of course, whatever I do to the left-hand side of the equation, I must do to the right-hand side of the equation. Otherwise, I change the equation. And so if I do this to the left, I must also do it to the right. I must also divide 84 by minus 7y. All right, what do I get? My minus 7's above and below will cancel. They're inverse operations. You're multiplying this side of the equation by minus 7, but you're then dividing it. I apologize. I made a mistake. There should not be a y there. It should just be minus 7. I have multiplied by minus 7, and so I've divided by minus 7. And so that is the same as, essentially, if you like multiplying by 1, these will cancel above and below. And so I'll be left with, on the left-hand side, y is equal to 84 divided by minus 7. All right, 84 divided by minus 7. You need to break out your calculator if you like. This is a time where knowing your times tables is very useful. 84 divided by 7, well, 7 times 12, if I'm not mistaken, is 84. And so therefore, 84 divided by 7 is 12. But of course, this is a positive number, 84, divided by a negative number. And so overall, that is negative. And so I have 84 divided by minus 7 will be minus, plus over minus gives me minus, 84 divided by 7 is 12. And so I get y is equal to negative 12 as my answer. All right. Again, you could plug that back in here. You would get minus 7 times minus 12. Minus times minus is a plus. 7 times 12 is 84. And so we had 84 equals 84. I think you can verify that for yourself. All right, let me give you a problem that you can now tackle yourselves. Try this one. 4y equals minus 36. So try that one yourself. 4y equals minus 36. Very much like the one we just did. All right. I call those problems that we've just done so far one-step problems. The reason we call them one-step is sort of self-explanatory. There was only one thing we had to do. Either add a number to both sides, subtract a number to both sides. In the last case, we had to divide both sides by a given number. One step, one thing we do, and then we're able to isolate the variable. Most of the time, it won't be that simple. There may be more steps that we have to do. And so now we're going to move on and we're going to look at what is the next natural progression, two-step equation. So two-step equation. So here is an example of a two-step equation. 5x plus 4 equals negative 11. 5x plus 4 equals negative 11. Again, we're looking for the value of the variable that makes the statement true. That is what it means to solve the equation. Okay, so how do we do this? Again, we want to isolate our variable. We want to have x equal to, and then everything else on the other side of the equation. So the first thing we notice is that we don't have just 5x on the left-hand side of the equation. We now have two terms on the left-hand side of our equation. And so we want to first get that from two terms to just one term. And so the way we're going to do that is we're going to subtract 4 from both sides. That's essentially what we're going to do. So we're going to have, on the left-hand side, I'm going to have 5x. If I subtract 4 from the left-hand side, I get 0. Plus 4 minus 4 is 0. Is equal to, I have a minus 11 here, but I have now subtracted 4 from the left-hand side, and so I must also subtract it from the right-hand side. And so I subtract 4 from that side. Okay, gathering my terms together, I get 5x equals minus 11 minus 4. Yeah, if I'm not mistaken, that's minus 15. And I'm almost done, but not quite. I've taken a big step towards isolating that variable, but I'm not quite there. I don't have x, I have 5x. How am I going to isolate that? I'm going to divide both sides by 5. So if I divide this side here by 5, and of course whenever I do to the left, I must do to the right, keep that always in mind. I divide both sides of the equation by 5. These will cancel, above and below, inverse operations. And so on the left, I will have just an x. And on the right-hand side, I will have minus 15 divided by 5. Again, it's a negative number over a positive number, so I know that's going to be negative. And I have 15 over 5. How many 5s are in 15? Well, if I'm not mistaken, it's 3. And so that is my answer. X equals minus 3. Okay. Let me give you one to try yourselves. Try this one, 3x minus 7 equals 5. Try that one yourself. 3x minus 7 equals 5. All right. Here is a slightly more different. We're going to finish on this one, this problem. 3/4 x. 3/4 x minus 2/5 x equals 14. And we're going to try that problem. 3/4 x minus 2/5 x equals 14. Okay. Again, we notice that we have x's and x's on the left-hand side, so we should be able to bring these together. But again, the wrinkle here is that we have a fraction. How do we deal with this fraction? Well, it's actually not such a big deal. Typically what we would have done before, and what you've probably learned, is that you would find the lowest common denominator, lowest common multiple. I'm going to show you a slightly different way. We would notice that the lowest common denominator, hopefully we can work that out, is between 4 and 5 is 20. 4 goes into 20 and 5 goes into 20. I don't necessarily have to, by the way, find the lowest common denominator. I just need to find a common denominator, but the lowest common denominator makes things a little bit more convenient for me. So the lowest common denominator of 4 and 5 is 20. Both 4 and 5 divide evenly into 20. Rather than write this a fraction down here with 20 in the denominator, what I'm actually going to do is I'm going to multiply this side of the equation here by that common denominator, in this case 20. So I'm going to multiply this left-hand side here by 20. So I'm taking 20 times 3 over 4x minus 2 over 5x equals whatever I do to the left-hand side, I must also do to the right-hand side. Otherwise, I change the equation. That's not allowed. So if I multiply this side by 20, I must also multiply the right-hand side by 20. So I have 20 times 14. 20 times 14. And now I can proceed. 20 times 3/4 x. Well, the way I would look at this, I'm going to distribute in my 20 now. I'm going to distribute this in here. You could take out your calculator if you like, but what I prefer to see is I see that 4 into 4 goes once, 4 into 20 goes 5 times. And so, I'll say that again, 4 goes into 4 once, 4 into 20 goes 5 times. And so 5 times 3 is 15. And so I get here 15x minus, I can do the same thing here. 5 into 5 goes once, 5 into 20 goes 4 times. And 4 times 2 is 8. And so I get here 8x is equal to, on the right-hand side, I have 20 times 14. That happens to be 280. You can verify that for yourself. 20 times 14. And so now I'm almost there. I've really simplified it, and this is just like an equation that we've done now already. I have 15x minus 8x. If I'm not mistaken, that is 7x. Confirm that. 7x is equal to 280. Gathering up my like terms, x's and x's on the right and the left-hand side. And now in order to isolate x, I simply have to divide my 7x by 7. And so if I divide my 7x here by 7, I will get my x by itself, but of course I must also then divide my right-hand side. So whenever I do to the left, let's do to the right. My 7's will cancel, and I will have x equals 280 divided by 7. If I break out your calculator, it happens to be 40. So x equals 40 is the answer that we're looking for there. And so you notice that the technique here, what made this one a little bit more difficult was that you had fractions in your original equation that you had to deal with. And I think this is a pretty convenient way of dealing with those fractions by multiplying both sides of the equation by the common denominator in your fraction. And then of course, if you do it to the left, you must also do it to the right. And therefore you end up with integer coefficients. All right, so that is the answer. That is how we do that one. I'm going to give you guys a solution, or sorry, a problem to tackle yourselves. That problem is the following: 1/3 x minus 3/4 x equals 10. All right, so try that one yourselves. 1/3 x minus 3/4 x equals 10. That's very much like the one we just did. All right, so I will leave it there. This is one-step equations. In the next video, I'm going to show you how we go about using when we have variables other than x and how to distribute. Does the actual value of the variable, of course, doesn't matter. B's, T's, etc., etc. So we're going to try a few of those, and we're going to see how to distribute parentheses, brackets, etc. All right, so I'll see you in the next video.